8. Which of the following equations represents a line that is parallel to the line with equation y equals minus 3x plus 4? Well, if we're parallel, that means our slope must be the same. So slope of our new line must be minus 3. Which of these following answers has a slope of minus 3? Aha, note, every answer is in standard form. ax plus by equals c. So we might have to solve for y to figure that out. If I looked at the first one, I would subtract 6x and divide by 2. That would be minus 3 slope. Essentially, this is going to be y minus 3x plus 15 over 2. That would be parallel. That's going to be our answer. Okay. If I have a positive and negative x, y, that's a positive slope. So it's not going to be parallel to a negative slope. Same story for C. That's going to be a positive slope. I can detect that right from standard form. And in the case of D, I'm going to be dividing through by 3. So I'm going to get a negative 1/3 slope. That's not right either. A is the correct answer. Number 9. Square root of x minus a equals x minus 4. So if a equals 2, what is the solution set to the equation above? Okay, we have different points on these radical equations. If we want to solve them algebraically, we usually have to square both sides. That gives possibility to an extraneous or invalid solution. If we looked at it, the roots are pretty obviously going to be 3 and 6, and then 2 is an extra one in there, which is almost always wrong. So generally, we want to just start by plugging in, because even if we solve algebraically, we have to plug in the answers to check for extraneous solutions anyway. So let's set this up. Radical x minus 2 equals x minus 4. Okay? So what could be a solution? Well, let's just check our numbers. 2 minus 2 is the square root of 0. That's 0. 2 minus 4 is negative 2. 2 is not a solution. We kind of knew that already. 3 minus 2, the radical 3 minus 2 is square root of 1. That's 1. 3 minus 4 is negative 1. So this does not work. 3 is not a solution, which means our only answer could be D here. It must be square root of 6 for x minus 2 equals 6 minus 4. Square root of 6 minus 2, square root of 4 are 2. 6 minus 4 equals 2. 2 equals 2. That checks. If t plus 5 divided by t minus 5 equals 10, what is the value of t? Okay. Well, we could solve this algebraically as one approach. T plus 5 equals, multiply both sides by t minus 5. And we'll get on the other side 10 times quantity t minus 5. The t minus 5's cancel on the left. And we can distribute and solve. 10t minus 10 times 5 is 50. T plus 5. And I'm going to subtract t from both sides. I'll get 5 equals 9t minus 50. I'm going to add 50 to both sides. 55 equals 9t. T equals 55 divided by 9. The correct answer for number 10 is D. 11. X equals 2y plus 5. Y equals quantity 2x minus 3 times quantity x plus 9. So what do I have here? I have a line, a linear equation, and I have a parabola, a quadratic equation. And how many ordered pair x, y satisfy the system equations shown above? Well, you know the possibilities would be no solution, one solution if it's a tangent, or two solutions if it intersects twice. We cannot have infinitely many. That's just not possible in this case. Okay? So how do we figure out the answer? Well, we can set that up and solve by substitution. So let's go ahead and try that, actually. I would say x equals 2y plus 5. So I'm going to solve that for y. I would say 2y equals x minus 5, divide by 2. Y equals 1/2 x minus 5 halves. Okay? So now I'm going to go down and say 1/2 x minus 5 halves for y. 1/2 x minus 5 halves for y equals 2x minus 3 times x plus 9. Okay? And I'm going to want to multiply that out. So 2x minus 3 times x plus 9, 2x times x is 2x squared. 2x plus 9 is plus 18x. Minus 3 times x is minus 3x. Minus 3 times 9 is plus, or minus, sorry, 27. And that, of course, equals our half x minus 5 halves. I'm going to multiply both sides by 2. Okay? So x minus 5 equals 4x squared. Combine like terms. 18x minus 3x is 15x. But remember, I multiplied that by 2 as well. Even if I didn't show it. That would be plus 30x. And minus 27 times 2 is minus 54. Okay, so let's see if we can't simplify, set the polynomial equal to 0. Well, I would subtract x from both sides. I'll get 4x squared plus 30x minus x is 29x. Add 5 to both sides. That would be minus 49 equals 0. So this is a little bit complicated. Are we going to find a factored solution to this? 49 times 4. Are there any factors of that sum to plus 29? That could be 7 and 7 and 2 and 2. 49 minus 4, no, that doesn't work. 14 and 14, that doesn't work. The answer is simply no. This is not going to factor over the integers. Now that I have this boiled down to one quadratic equation, I'm actually going to just use my discriminant test to check if I have 2, 1, or 0 real roots. So I'm going to check b squared minus 4ac to see if it's greater than 0 or possibly equal to 0 or less than 0. So is it equal to 0 or is it less than 0? We know that's respectively 2 real roots, 1 real root, no real roots. So b squared is going to be 29 squared minus 4 times c, which is minus 49. Now, these are ugly numbers, but the minus is going to be positive. So the result here, whatever it is, it must be positive, which means I know the discriminant's greater than 0, and there are 2 real roots. The correct answer must be C for 11. Now, that took quite a bit of work to set up algebraically. Could I have seen something more clever to answer this more quickly? And I think the answer is yes. If I thought about this graphically, because we know how to graph these, especially in the factored form here, I know x equals 2y plus 5. Well, we said that's y equals half x minus 5 halves. So that's something with a slightly negative y-intercept, and it's a pretty flat upward sloping line. That's our linear equation. The parabola has roots of 3 halves and minus 9. So the roots might look something like minus 9 here and 3 halves here. And it's going to be upwards with a coefficient of 2, so it's going to be fairly steep. And somewhere in between here is going to be a minus 4 for the axis of symmetry, very roughly. It'll be the average of these. So if I square that, I'll be at minus 16 for the y value of my vertex. But then I actually have to multiply that by a coefficient of 2. So I'm roughly minus 32. I'm kind of way down here on my vertex. And if I draw that in, well, I can clearly see, regardless of not being exact, I am going to have 2 real roots, 2 actual intersections between the graph, which tells me pretty quickly and without all the algebra that C is the answer for 11.